Today we're going to use our factoring to solve the quadratic. So now we have an equation and we're going to look for solutions. Um, if you take a look, we have quadratic functions, ax squared plus bx plus c, quadratic equations here. The difference here, this is a function because it's set equal to y. That actually means you have many solutions because you have all the xy points that are on the graph. When we say that we want to solve quadratics here, if it's a function, then we're assuming that we want the solution when y is equal to 0. So we're actually looking for the x-intercepts. Okay, so if you're talking about a graph, you're looking for the x-intercepts whenever you solve a quadratic function. Okay, when y is turned into 0. Okay, the other thing we need to refresh is the zero product property. And that says if you're multiplying factors together and the answer is 0, then something has to be a 0. When you multiply here and the answer is a 0, then one of these factors has to be a 0. And that's pretty easy to work with. It makes it nice to finish the problem. All right, so we're looking at this. This is a quadratic equation. It is already equal to 0. And the problem is we can't just cancel stuff to get x alone, to isolate it. What we have to do is break down this x squared into the factors, okay? So we know that x squared can be split into x times x, right? And then we're looking at the 16. This would be 1 and 1 here. The 16, we have some options. It could be 16 times 1. It could be 2 times 8. Oh, I forgot 4 times 4. Okay? And something has to be a negative in order to get the 6 in the middle. Okay? So really, all of these work for a 16 if we made one of them negative. But I need to get this middle to work for 6. So look at your options. 2 and 8 has the best chance. Okay? So when I check this, this would be 8x, this would be 2x. I need to keep the 8 positive. I need to make the 2 negative. And now I have factored that quadratic. Next up, the factoring is actually the harder part. Next step's easy. If we are multiplying this and it's equal to 0, that means either x minus 2 is equal to 0 or x plus 8 is equal to 0. So you take your factors, you set them equal to 0, and that is not a 2. Let's fix that. Okay, so there we have a 2. And then you add 2 to both sides, and you get a solution of 2 for x and a solution of negative 8. So there are 2 solutions here, mainly because this has a degree of 2. All right, so we have 2 x-intercepts. This would mean that our parabola would cross at negative 8 and at 2. A little review here, so it would be something like that. So this would be the point 2, 0, and this would be the point negative 8, 0. Okay? All right, so all that stuff there. Remember, they're called zeros. X-intercepts when y is equal to 0. They're called roots, solutions. Let's try this one. This one's equal to y, and we want to know when y is 0. So we're just going to insert a 0 right there. And we need to factor this. Now, factor. Do you remember grade 1 factor? We can divide all these by 2. I'm bringing back some good memories there. I say factor. This is nice because that brings that down to a 1. And so that decreases our options here. This has to be 1x and 1x. And then for 30, it could be 30 and 1. It could be 2 and 15. It could be 3 and 10, 5 and 6. We have lots of options here. One of them has to be negative, and I gotta get a 13 in the middle. So if you look here, these two both have a chance, okay? If the 10 and 3 were both negative, I could get a negative 13. However, when I multiply, I need a negative. So only one of them can be negative. That means this is the best option. I need to have a negative 15 and a positive 2, so that adds up to a negative 13, and this multiplies to a negative 30. Okay, now we set all our factors equal to 0. Well, if I set 2 equal to 0, that does not have an x with it. That does not give me a solution. 2 does not equal 0. There we go. All right, if I take x plus 2, set it equal to 0, and x minus 15 and set it equal to 0, I would subtract 2 on both sides, and one solution would be negative 2. And one solution would be 15. Okay. All right, one more. Let's take a look here. It is not set equal to 0. It is not equal to y. We need to make this equal to 0. Okay, we have to use that zero product property. So we're going to add x to both sides to turn that into a 0. Okay? Now, when we look over here, none of these are like terms. I do not put the x's together. I do not put the 12 and the x together. I do need to put them in order, though. Okay, so we add the x here, and then the minus 12, and now it's ready to factor. There's no greatest common factor. I'm just going to take the x squared and break it up into x and x. The 12, we have options. It could be 12 and 1, 2 and 6, 3 and 4. I need one of them to be negative, okay? But it has to add up to a positive 1 in the middle. So this is our best option. Let's see. If we use a 3 and 4, and we multiply this, that would be 4x and 3x. I need the 4 to be positive and the 3 to be negative, so I get a positive 1x. All right, then we finish it off. This is the easy part. Set that equal to 0, and x equals 3. Set this equal to 0, and x equals negative 4. And there's our two solutions.